Okay, so at the end of the last video, we talked about how to add vectors using the method of components, and we're going to start this video off with an example showing just how to do that. So we have a mail carrier that's going to leave the post office and drive 22 kilometers in a northerly direction, straight up. Then go in a direction that is 60 degrees south of east for 47 kilometers. What is her displacement from the post office? So basically we have two vectors that we need to add. We have the vertical vector d1, that was 22 kilometers straight up, and then 47 kilometers along this direction that makes a 60-degree angle with the x-axis, or east. So it's 60 degrees south of east. Okay. Let's just verify, is that right? 22 and 47. Oh, and they're 0.0. So I should make a note of that. That'll affect our significant figures, 22.0 and 47.0. So what we want to do is, we've already got the diagram here. We've got our x and y axes set up. We want to break each vector down into its x and y components. That's easy to do with the first vector. It's straight up. It's only a y component. The second one, though, is diagonal, so it will have both x and y components. It goes to the right and down. So let's go ahead and advance the slide here. Yeah, I've got my x component there and the y component there. So I need to find out what those are. Once I do that, then I can add the components in each direction, and then once I've got that, I can find the magnitude and direction of the result. So as I said before, I like to set up tables when I use the method of components. So we've got D1 and D2, and I want to find the x and y components of these. Now D1 here is just straight up. So its y component is 22.0. The x component is 0. It doesn't go to the right or the left. D2, however, does have both vertical and horizontal components. So I need to calculate what they are. Theta sub x is 60 degrees. This angle that I've been given is, in fact, the angle with the horizontal, which is what I want, theta sub x. So that means that d1 in the x direction is going to be d1 times cosine. It's always cosine for the x component. Cosine of theta sub x. And d1 in the y direction is going to be d1 times sine. And again, sine is associated with the vertical direction, times theta sub x. Okay, so d1 was 47.0 times cosine of 60 degrees. And down here we have, again, d1 was 47 kilometers. This time we're going to multiply by sine of 60 degrees. And if I calculate these two values, they are 23.5 kilometers and 40.7 kilometers. So I've rounded that off to 3 decimal places, or 3 significant figures rather, because that the data that was given to me in the problem statement was 3 significant figures. So my x component is 23.5, and my y component is 40.7. Now we can add these columns, add together the x components and the y components. 23.5 plus 0 is just 23.5, and 22.0 plus 40.7 would be 0.7 62.7. So this is the x and y components of the resultant. So I'll just advance the slide here. You can see, yep, there's my x component, 23.5. The y component is 40.7. This is a good point here that we should that I overlooked. This is why it's important to draw the diagram. This y component was down. Okay, so it was going in the downward direction. According to our convention with our xy coordinate system, a downward direction is negative. So this should be negative 40.7, which means that 62.7 is wrong. So let's erase that. Okay, and instead, that should be negative 18.7. So I've corrected that. So yeah, in the x direction, I add together the two components, get 23.5. And in the y direction, keeping in mind that should be negative, 22 minus 40.7 gives me negative 18.7. So that is the, those are the components of the resultant. And I'm going to erase what I've drawn here so that the diagram can come in here. Hold on a second. Okay, so I erased some stuff here so that I can now advance the slide, and looks like I might need to erase a little bit more. Let's clear this up. Okay, so essentially what we have done by adding these components, these x and y components, is found the x and y components of the resultant. So our x component of the resultant is 23.5. So the male carrier, compared to her starting point, ended up 23.5 kilometers east and 18.7 kilometers south of her starting point. So this is where she started. This is where she ended. So what we want to know is, what is this length? What is the length of this hypotenuse? That would be the magnitude of the resultant. And what is the angle that she makes with the east direction? Okay, so let me advance the slide here. Oh, I've already got it. I thought this would be animated and fly in on my click, but it turns out it's already there. So giving away the answer a little, but that's okay. So yeah, we're using the Pythagorean theorem with these two legs to find the magnitude of the resultant. So a squared plus b squared equals c squared, or 23.5 squared plus the negative 18.7 squared. Now when we square a negative, that becomes positive, so the negative sign's not really important there. But we square these two, add them together, take the square root, and we find that the distance the mail carrier was from her starting point at the post office was 30 kilometers. Okay, but we're not done, because vector has to have magnitude and direction. We need to describe the direction she is from her starting point. So looking at this right triangle, if we wanted to find tangent of this angle, it would be opposite. This is the opposite side over adjacent. So TOA, opposite over adjacent. And so if tangent of theta is opposite over adjacent, then theta itself is the inverse tangent of opposite over adjacent. So that's what we have here. Inverse tangent of the opposite side, negative 18.7, over the adjacent side, 23.5 kilometers. So the inverse tangent of that is negative 38.5 degrees. So it's common to consider the positive x-axis, or due east, as 0 degrees, and then straight up is 90 degrees, and to the west is 180 degrees, and straight down is 270 degrees, or we could say negative 90. So this is what your math teacher probably uses teaching you the unit circle for trigonometry. It also happens to be the same convention that AutoCAD uses for angles. So when we say negative 38.5 degrees, that means we're starting at horizontal and moving down 38.5 degrees. So that's the direction of the vector. So we have found the magnitude and the direction, and that's required when describing a vector. Let's look at another example. This is using the same method of components, but this time we are going to be adding 3 vectors instead of just 2. And so the first leg is due east for 620 kilometers. The second leg is southeast, exactly southeast. So it's at 45 degrees for a distance of 440 kilometers. And then the third leg is 53 degrees south of west. So meaning that if we started with due west, and then we come down from that clockwise 53 degrees, that's the direction we're talking about, 53 degrees south of west, and that distance is 550 kilometers. What is the total displacement? Okay, so again, we have a diagram. We've drawn a diagram with our first vector, due east, then we have a southeast, and then a southwest. These diagonal vectors, we need to break them down into their horizontal and vertical components. And then create a table, add all the vertical components, add all the horizontal components. Okay, so let's make our table down here. We've got D1, D2, and D3. We want to break them down into X and Y components. So if I redraw a diagram here, our D1 was perfectly horizontal, due east 620 kilometers. Then the next leg of the journey was 440 kilometers at a 45-degree angle. And then the last was southeast. It was 550 kilometers, and it made an angle with the horizontal of 53 degrees. That's 53 degrees south of west. So if we start with D1, D1 here, its X component is 620, and its Y component is 0. Now let's look at D2. D2 is diagonal at a 45-degree angle. So D2x is going to be the magnitude of the diagonal vector, 440, multiplied by cosine of 45. That equals 311 kilometers. So over here in my table, I'll put 311. Now, D2 in the y direction is going to be 440 times sine of 45. Now, if you know your trigonometry, you know that cosine of 45 and sine of 45 are the same. So this is also going to be 311 kilometers. But what we need to be careful of is this is down. And in the y direction, down is negative. So we need to make sure that we make that negative 311. Forgetting negative signs is definitely the most commonly made mistake here. And as I look down at my timer, I'm just about out of time. So I'm going to have to stop here and finish this problem in the next video.